Okay, welcome to the next stream of Introduction to Structured Programming. Today we will continue with everything that remained from the last time, and we will build on top of that. So it will be very interesting today, and we will also implement a little but very nice program so that you really also get an idea on how to get started into programming in C. And yeah, I don't think we have much time that we should lose. Let's start.
Okay, let's start with the organizational part. First off, the grading. So the first block of coding sessions is now also available on the grading website. So not the Teach Center grading, but there's a link on the Teach Center to the website and also on the course website. And homework 2 will probably release over the weekend, also on our grading site.
Then there is one announcement regarding the coding sessions. So next week, the third block of the coding session starts, and today we released the time slots, so you can already register, and we also released the first pre-work task. And there is some change because it was a bit annoying, the old report format on the TU Graz cloud. So we changed this and put this into the Teach Center. So I can also demonstrate this here. For the third block, this is a Teach Center activity. It looks like a test, like an exam, but it's just to submit the report, so no worries. And I hope this works better than the TU Graz cloud. And there's one more thing.
Yes, so assignment 1 is coming to an end. So there will be a question hour as announced last week and the 20th. So next Monday.
Yes, next Monday.
It will be in EI9. So yeah, you can ask the general questions and also get some individual support. So yeah. Also, of course, the personal question hours are still available. You can register for them in the Teach Center. Yeah.
Yeah, so that's everything from the organizational part. And now...
Oh, and it starts at 18 o'clock and not 16 because we switched it because I think you have NRLR there. So it starts at 18 o'clock.
And no, there won't be a stream for the question hour. So it's more something individual. There will be also a couple of tutors there and you ask them questions there, and it will not be streamed or recorded or anything like that. Yeah,
so if you're stuck on something, you can go there, ask some questions, maybe you can solve it, finish your assignment or something.
Okay, and then as usually, we continue with a Menti Quiz. All the topics we cover. Oops. Nobody saw anything. Yeah. But just we have to go back to the first question. The link is as always in the video description, and we have something around 200 people in the stream. Is that right? 150. So maybe we wait for a couple of seconds.
I don't know how you can find your mentor, but your tutor will be assigned at the end of assignment 1, and you will then know what your tutor is. Yeah.
And where can you see the assignment? How does it continue, this question?
I think it's just,
Where can you see the assignment? It's uploaded on GitLab. So just gitlab.tugraz.at, and then there should be a repository called ESP WS23 and then some number, and that's your assignment repository.
I think there was an announcement on Discord. You can also check the link. And also the video that was announced. Oh yeah, so we
start with the question. How can we compile ESP.c to a program named bin?
So this is just about the command you have to write to compile a C program.
Yeah, so everyone is awake now because we started very quickly. I think there were like 100 participants in the Menti. So yeah, it works that everyone can answer.
Yes. So most of you are correct. Some of you switched the -o flag. You need to specify the name of the binary after -o and then somewhere the C file. So that's important that the binary always comes after the -o because the -o is for output. Okay, then let's continue. So the next question is how can we run a program named bin? So we just compiled it, now we want to run it.
There was somebody who created the Menti and did the mistake in the question. So we just want to run it, not to compile it. I'm sorry.
Yeah, I also didn't spot that, so...
You even read that and...
Yeah.
But yeah.
Okay, so most of you got that right.
Yeah, I hope that nobody answered none of the above because of my mistakes. I hope that's fine.
Okay, so...
Question number 3. And now I want to mention it's a bit a harder question, maybe at the first glance. And you have more time. So
take your time.
Yeah, take your time. So you have some printf here of some expression, which is not 42 and 123 or 0 and not -1. And what is the result of this expression? Yeah, good that we gave you a bit more time because you really have to think about it.
I hope it's enough time.
The number is rising. Okay.
Okay. So I think at least most of you realize that if you have a not here, the value has to be 0 or 1. But yeah, if you evaluate all of this, you have here not -1. So -1 is a true free value. So we have something that's wrong, and because we have just ands here, this whole expression here is wrong, and we have a not before, so we have a 1.
Okay, yeah. So it's true.
Yes, I hope that was clear. So let's get to the last question, which
looks like this.
Which maybe is already familiar to you.
But we did a slight change maybe in the question.
Yeah, maybe we changed it a bit.
Yeah. So we have this program, and you should predict the output, and we start the question. And maybe you open the code again.
Are there any questions?
I hope that there is no image there. No, there is none. Yeah, everything is right. Okay. Okay. I'm not sure what the problem was there. No. Okay.
I was just reading a chat.
Yeah.
Okay. So yeah, it's pretty split between output n and compiler error. So as we saw last time, when you declare a variable within a block, so within this if, then it's only valid within this if. And because we only have adult in here and in here, printf will give us an error. So I can also press run, and
yeah, the last message is here. If you scroll down, the last message is here.
Error
of undeclared identifier adult, and that's because we declared adult inside of a block here and want to use it outside of the block.
So it's undefined outside.
And this was mainly the topic that we discussed last time. Yeah. So,
okay, so
in general, the results were better on the Menti, but still many of you answered in the wrong way. So we should maybe repeat that.
So the recap is the variables are only valid within one block. So if you define a variable within an if statement, then outside of the if, it's not valid anymore. So you can't access it because it doesn't exist anymore. Maybe you remember the stack example we did. And the additional thing is, so if you define a variable outside of a block, then nested blocks can access these outer variables. So if you would have defined char adult outside, then you can access it within the if and set it to y or n. We also did that last time. So if you have trouble understanding that, I think you should rewatch that part of the last stream.
Okay, that was the recap. And now we continue with a new topic that you heard in the last lecture, which is functions. And I think we will also give you a short recap what functions are. But I think this is also your part.
Yes. So first, let's define a function. How can we define a function? So a function has a return type, which is down here integer, but this return type can also be void. Then a function doesn't return a value. So this is different because integer is like a type you can use everywhere, and void can only be used in some situations. And for example, that's the return type of a function which doesn't return anything.
So could I also return, for example, a double there?
Yeah, you could return a double, but not if you like wrote void.
Okay, yeah.
Then a function also has a name, which follows after the return type, and a list of parameters, which are within these parentheses after the name, which also have a type, each parameter, and a name. I think that's pretty clear. That's also like how you would declare such a variable. And and then like with an if or a while statement, you have these curly brackets where you can define the body of your function, which consists of multiple statements.
Yeah.
Or it can exist of multiple statements.
Then we have the question in the chat whether it's the same to return 0 or that we have a return type of void. Yeah, would you like to answer it?
There is a difference. If you return the type 0, then when you call the function, you can use that value. You can say, okay, maybe add 3 to it, and then you add 0 to 3. But if you have a function that returns void, and then you try to add 3 to it, you get a compiler error because you can't do anything with a void type.
Okay, so we want to write now a first function, and a very natural approach is that we take some mathematical function and try to write it in C. And later on, we will also see other examples of more computer science related functions. But we will start with a mathematical function to demonstrate now everything, how to write it in C. Okay, so I will do this now here in our code editor in VS Code. So I already prepared a main function here, and now I want to write this function x squared plus 3 that I showed you. And the first thing that I want to do is I declare now an integer, a double x, and I give it some value, for example 4, doesn't matter. And then I would like to obtain the result of my function. So my function is f of x, which I have not implemented yet, but I will do this right now. And I want to assign the result to a variable y. Yeah? So this f doesn't exist because we haven't implemented it yet, but that's how we want to call it. So we want to give it this x, and we want to get the function value returned. And then I'm a bit lazy, I will just copy it now. I want to just to print the result here. Yeah, what is the outcome of my function? So how to write actually this function now? We have seen we need the return type. And if we go to the slides, in generally, if x is some double, then the result of the function value is also some double. So it's probably beneficial to choose double as the return type. Then the name of the function is now in this case f. In general, you should use names that express more, but now this is enough for the first example.
We just chose this name because maybe it helps you if we just somehow find parallels to mathematics.
Mm-hmm. And what do you want to have as a parameter? This is just the argument x. So we write here double x. Okay, and that's already the signature of the function. So return type, name, and list of parameters. And now in the function, we can do what the function is about, and I will do this step by step. Of course, we can do this within one line, but I want to show it step by step. So you could say, first we multiply the x with the x to obtain the x squared. Then we add 3 to the obtained value from x squared, and then finally we return this y. Of course, we can do something like return x times x plus 3 immediately, but I just want to do it step by step to show you a bit more in a few seconds. Okay, that's the way we write the function, and as we have the question in the chat, this is just a format string for doubles. Okay, now we want to compile it. It's called main, and we run it, and we see now, okay, if we insert 4 into our function, so this is the x, then we get the result of 19. So 4 times 4 is 16, plus 3 is 19. So it looks quite good. Okay, that's the way to write functions in C. Is this clear to you how to write such a function, or do you have any questions just on this part? But we will have a closer look now on what is happening internally.
Maybe let's just compile it with debug symbols.
Okay, yeah. Yeah, you can format the output, of course, in the printf using, for example, 4.2, that you do not have this, I don't know, 6 decimal values after the dot, but you don't need to. No, the parameter in the function does not need to be initialized. So we could, in generally, if we have an x here,
it has to be initialized.
It has to be
initialized.
But we could also write something like this, so we don't need to input a variable there.
Yes, it does need to be defined before the main, but it's also enough. No, it does need to be declared before the main, but it's also enough if you just declare it before the main and then define it later. But I think we won't get into this difference now.
We could actually. It was discussed last lecture. It was discussed.
Okay, then let's just quickly go over it. Defining a function means that you specify what the function actually does, so you provide a body. And declaring a function means just telling the compiler that there is a function which has this signature, which looks like this. So now I could do something like this. Okay, I declare it before the main. Then, okay, the compiler knows there is a function that exists that's called f and takes a double and returns a double. So the main function now makes sense to the compiler because it knows what f is. And then later we actually define it what it does. And we can try to compile it. It works if we comment that out.
So we don't declare it?
Yeah, so we don't declare it. We just define it, but after the main. So we also declare it here, but we don't declare it before the main starts. So when the compiler looks at the main function, it sees, okay, f does not exist.
So actually it's the warning, and then we have some other problem there.
Yeah.
Yeah. But it tells us, okay, there's something wrong at least.
So if you do it like that, it works again.
Oh, David has a question. What if I have no parameters? How does the function know which parameter is which variable?
What if I have more parameters?
I have more parameters.
Yeah. Maybe let's copy it back up so we don't have to change two function signatures. Yeah, do you want to answer this?
I answer this. So if we have a second parameter and I now create also a tuple and I call it set to not have a naming conflict, and then I also have to pass another value, for example 4.2. Then the first parameter in the function call matches with the first parameter in the function declaration. Second parameter matches the second parameter in the function call matches the second parameter in the declaration.
So it's always about the order, not about the name. We could, for example, pass x to the second parameter, and now set would still be the value of 4. Because, yeah.
And it really doesn't matter how you do it in the assignment, but probably it's more convenient that you have the declarations on the top and then the implementations at the end. So if you look at the file the first time, then you immediately find the main function, and you also do not have a problem if several functions need another function, and then in which order do you have to arrange them that it works.
Yeah, also I think it's a bit clearer if you open the file and immediately see all the functions that there are, and maybe also the comments for these functions, what they do. Then you don't have to read the code and you can immediately understand the main function.
Okay, then we have this function implemented, and now we want to have a look on the stack and what is happening internally. So let's see whether this works. And exactly.
Okay, so it works now.
And we also see the whole code. This is really nice.
So do you want to...
I debug, yeah? Okay, so I start the debugger now on the right side, and we already have a breakpoint in line 12, so we should stop there immediately.
Oh, we didn't compile after.
We didn't compile, so we redo everything. Terminal. Okay, we are in the wrong terminal. So you don't see the mess that we have right now, but now it should work. Yeah, everything is fine. So yeah, this looks very good.
So if you see something like that we had here, that the compiler is breaking at the wrong, so the debugger is breaking at the wrong line or something, that's probably because you aren't debugging the most recent version of your program. Yeah, because when we compiled it before, all the line numbers were different, and now because we moved some code around, which also, which means you stopped in the wrong line.
But now it works. So we had this tuple x equals 4, and what is happening on the stack right now?
So on the stack, we are entering the main function. So we can see, okay, there's something on the stack which indicates we're in the main function now.
Okay, so we step one step further. What have we done now?
Now we declared and defined a variable called x, which is in the main, and it's now on the stack because that's where our local variables are. Okay,
and we also see here we have the value 4 assigned.
Maybe you can also see something interesting, that the variable y has some random value in it right now, because it exists, but we haven't assigned any value to it yet.
Okay, then we continue. So we jump now into this function.
So we now are in function f,
Mm-hmm.
but when we call a function which has parameters, also the parameters are immediately put on the stack.
Mm-hmm.
So now we have the function f here and the double x.
I will also demonstrate this in the debugger. Now I'm here in the function f, and I here have this variable x. And if I click here on the main, I also have this local variable x, which is the old one from here. So in both functions there exists now an x.
And we can also see that the y has different values.
Yeah. So
The values are random because we haven't assigned anything to them yet, but they are different because they are different variables.
mm-hmm. So I go one step further.
Mm-hmm. This also means, okay, let's just copy the, do it like that here. Okay, we have the y in this function now. It has the value 16, as we can see in the debugger.
Mm-hmm. If I go to main, then the old y, which we do not really have created yet, has also some random value, but in our function f now the y has really the value 16.
And we can see that in this illustration because, okay, this y is clearly different to the one we don't have defined in the main yet,
Mm-hmm.
but we can also see that the x here is really different than the x that's in the main.
Mm-hmm.
And that the compiler does it automatically for us. So this x here has the same value than this x here.
Yeah.
So this value gets copied into this new variable x in the function f.
Yeah.
But they are different.
Then we go one step further. So we just simply add 3 to the y. I think we don't have to demonstrate this on the stack. And then the next step, we go back to our main function.
Okay, what happens now?
Yeah.
So we have all of these variables, but we already exited the function. We returned from it.
Mm-hmm.
So what happens now is that all variables are popped from the stack and we are back in the main.
Mm-hmm.
So now all variables that are in this function don't exist anymore. And our y variable is created with the return value of the function f.
Which was 19 in our case.
Yes.
And I already clicked one more step in the debugger, and we also see that 19 is now
I can write
on the
it
stack
here.
of the main function. Yeah, okay, and now then the next thing is printing, and then we don't care about it anymore because we left. Or I went into the printf function, but it doesn't matter because nothing else is happening here. So we demonstrated to you now the debugger and the stack simultaneously for this function, and the takeaway is really that everything is copied into the function, and variables that live inside of the function f here do not live in this main function, or vice versa.
And contrary to if you just declare a block within a function, if you call a function, that function doesn't have access to the local variables the caller function defines. Yeah. So if you are within a function, you can only access the local variables which are were defined since entering the function.
Okay, was that clear to you in the chat, or do you have any questions regarding this topic? But we will do another example soon, right now, if you don't have questions. But if you have questions, please ask them right now. But maybe we change back to our original setup. Yeah, and I think it doesn't look like there are questions, so I will just prepare everything for you. Okay, then we continue with the next example. Do we have a slide there? No, we just continue with the next example.
Maybe something about the last example I want to mention.
Okay.
We always talked about scope versus lifetime, and so they were the same in the last example we discussed, but if you notice in this example, they are different because in here...
Can you maybe again tell us what scope and lifetime means?
Okay, so the lifetime tells us how long a variable lives, how long it exists, and the scope means where we can access this variable. And here they are different because if we consider this function f, maybe line 5, we are right now here, then the variable x of the main clearly still exists. So it's still, the lifetime is still there, it still exists, but we are in a different scope, and this x here is not in scope. So if you would call this something different, like z, we can see that if you would, I don't know, try to return z here, we get an error because z is not within the scope of this function. But it still has to exist because maybe we want to use it later in the main.
So it exists in the main function and we can access in the main function, but in the function f, it still exists because the main exists, but we cannot access it because we're not in the right scope.
Exactly.
Okay. Okay, and also in the meantime, no more questions came up, so we then really go to the next example.
Okay, now I can remove that again. Okay, so
what is your plan?
Let's say we have two integers. Let's just define them. We have a and b. And now we want to write a function which swaps those integers. So let's write it. We don't want to return anything because we just want to swap those. Okay, we call the swap function, have specified these two parameters, so parameter a and parameter b, the second one.
So this a would then have the value 4.
Yes,
and the b,
the value 8. So if you want to swap something, we need a third variable most of the time. So let's create one, assign it to a, then assign the value of b to a, and the value of our temporary variable to b. So now, when we are here, we swapped those two values. So the value a, the variable a holds the value of b, and the variable b holds the value of temp, which was the previous value of a. So we swapped them. So my question to you is now, what happens? I'm also lazy.
Yeah.
If we print the values a and b after the swap function here.
Okay, so you want to tell me now that we swap those, so a should be 8 and b should be 4, right? Okay.
So
that's
a question for you now to think about. What are those values?
No, the people in the chat are complaining that this is not true what you told us. Or is it true and it's just two people who wrote something?
Maybe they just don't understand.
Yeah, maybe someone can confirm that. Is it true that they changed or did they not change, as those two people wrote in the chat?
Maybe let's already compile it. Then we can check. Okay, so many of you are saying that they didn't change. Let's confirm that. Yes, they actually didn't change. But
come on, you're studying for 2 years and you can't change the variables. What did you do wrong?
Maybe let's look at this stack again and let's try to figure out what went wrong. And also use the debugger again.
Do you want to draw the stack or should I draw the stack?
You can do it.
Okay, now I draw the stack. Very nice. Okay, so we are in the main function.
So as you can see at the start, a and b have, because we didn't assign them yet, have some random values. Let's go over that. Okay, so a and b is now assigned.
We have those variables here. Very nice. I would also write the values here maybe.
Yes.
Mm-hmm.
So let's let's just describe the difference between these two buttons.
They don't see them.
Oh. Okay. Step into when you're using the debugger. Maybe I can move it over here, then they see it.
No. There's our.
I can move it over here. Step into means if you are on the line where a function call happens, then step into lets you debug the function, and step over would just skip the swap function and directly go to the printf. So right now we want to click step into because we want to look at the swap function, what went wrong.
So we are here.
Yes, and we are assigning the temporary.
Wait a second, I'm not that fast. We have two parameters in the function, a and b, and a has the value 4 and the b has the value 8 because they get copied into the function.
And we assign the temporary variable.
Okay, to what value?
To a, so 4.
To 4, yes.
Okay, so let's continue one step.
So a equals b, so we have here the value 8.
And now b equals temp.
B equals temp, so this b should also have the value 4 now. So they swapped, right?
Yes.
So this a has now the value 8, and this b has now the value 4. Everything was fine, right?
But maybe we will find our error now. So let's continue and go back into the main function.
Okay, so we go back to the main function.
And now everything that happened within the swap function is gone.
Okay. Oh, we are left with 4 in the a and
now nothing happened in main.
Okay, yeah. So because we didn't touch the variables in the main here, those two variables. We just changed it in the swap function and not outside. Very interesting, yeah.
But now if I want to get the values back, I also couldn't return them because there are two values.
So a function can always return one value?
Yeah, so we have one return type. How would I return now both values if I actually want to swap them?
I think we need to wait for the lecture.
I think we're not prepared to tackle this problem yet.
Yeah. So we really have to wait for the lecture. But
maybe next week or in the lecture.
Yeah, in the lecture, I'm pretty sure. But maybe you can explain what happened here and how this is called now. The way the parameters are passed to the function.
Maybe just 2 questions from the chat.
Yes.
So we quickly, because someone asked if we learned how to use debug yet, we quickly went over it at the beginning of the last stream, and now today maybe a bit more in depth.
Yeah, and so, to set it up, there is also some description in Notion, which David wrote this week. And why do we start in the main function and not in the void?
So not in the swap. We always start in the main. So that's how it works with most of the time. In C, you start with the main function, and it can be declared and defined anywhere in your program. And it doesn't matter which function is at the very top. We always start with the main function. And unlike in Python, you also can't write anything outside of functions. You can just write code within functions, except like variables. Yeah, and there's one suggestion that we should return an array or call by reference, or whatever this means. Returning an array can be tricky in C. So we will not show this to you because this can lead to some problems. But maybe we will remember that for next week to show what happens when we try to return an array from a function. Yeah, that's a good idea. Okay, so let's go back. We also have those implementations in the slides, so you can look them up afterwards. And what we just observed is called call by value, which just means that all parameters are copied to the function you're calling, and the called function can't access any variables which were declared in the caller. So the callee can't access any variables of the caller. Yeah. Okay, so this was the
more or less to sum up what we've seen now. And if there are some more questions on this topic, we would answer them, but then we would also have a look on how to structure a program. But probably I start with that, and if there are some questions, then we'll answer them in a few minutes. And now we have looked on some main concepts, we have looked on those loops, we have seen conditions, we have seen functions, but now you should program an assignment which consists of all of those parts. And maybe it's a bit hard to get started and to think how to structure the program, what to start with. And we want to give you some hints there and show you how to start. And for that, we will write a simple program. And you probably spotted it already in the editor. So we will write a very little rock, paper, scissors, where you play against the computer player, which randomly chooses one of those three. That's a good question that is in the chat. If I got a user input, should I have an own function or should I put it into main? And that's what we will also see here. Yeah. So we go to rock, paper, scissors, and I will just briefly explain what is already there. So we already have a main function, which is a hello world to start with. And then I have a function get input that returns me a character, what the user entered. And I will not show you this function today because you should do this on your own for the assignment. And I also have a second function which returns me a random number. So I will use this for the computer player. So those are things that are a bit harder than what I want to show you now. So we just assume that they're already there. Okay, now how to write this program. So our goal is the following thing. We want to play one round of rock, paper, scissors. This means the first thing that I need from keyboard layout is I need an input of the player. Yeah, so the player should input rock, paper, scissors. That's the first thing that I want to do. The second thing is I need let's say input, whatever this is, of the computer. So I need the choice of the computer as well. Once I have those two things, I can then compute the result.
So who won?
Yeah, so who won? Yeah, I'll write this here. And yeah, based on this, I can output, okay, this player won, the computer won, or if it's a draw. Okay, and that's already the structure that we need. And exactly this is what we want to have in the main function. So how to store an input of the player? It could be beneficial that we say rock is an R, paper is a P, and scissors is an S. So we can store it as a character, basically. So we call it, we create a character player input. And now we want to call a function to obtain the player input. And I will call this function just player input. Does it need to take parameters? Probably not, because we just want to get a character. And we want to store it. So we have one return value and no parameters. So this is the first function that I will need to write. So there will be a function called player input, which doesn't take any parameters and which is a to-do. Then the next thing is the input of the computer. Same thing as before. So we have a computer input. And I also write the function for that. And that's basically the same as here, but it will probably look a bit differently. Computer input. And the last thing is we want to compute the result. And now we have to think about some way to represent the result. For example, we could say that -1 means lost, 0 means draw, and 1 means it's a win for the player. We can, for example, choose this representation here. So this would really map to an integer here. So we get another integer, which is the result, and we now want to compute the result. And now, in this case, we need two parameters because we want to input the player input and the computer input to this function and determine then who won the game. So we have player input and computer input. Yeah, so basically this is everything the game is about in a very large view. We just need the input of both players, we compute the result, and that's it basically.
So couldn't you use a signed char? I guess for the result, yes. So here you could also use a signed char. Important that it's signed, because you don't know with a char if it's signed or unsigned, so specify signed. Then you could represent -1, 0, and 1 also with a signed char. And it would use less space, but it doesn't matter.
Yeah. Okay, and based on this, we can, for example, print then the result. So the result equals 1, then we write 1, and if the result is 0, we write like it's a draw, and oops. And if the result equals -1, we write lost. I don't know, something like that. And this is then the main function, and we're done with the main function. Now we propagated our problems to actually implement it to these smaller functions, which we have here. So I need also to the compute result function, I need this here. So character player and character computer. Okay, and those are our next 3 to-dos. Yeah.
So else if, yes, we could use else if, but it would be the same result now, just that else if may be a bit more efficient, but it's such a short program, it doesn't matter, and there are very, very little cases where it actually matters, I think, from a performance point of view. But yeah, you could use else if here. So in this case, you're saying, okay, if the result is 1, print 1, and then you skip over everything because we just have else's and return. And if it's not 1, we check if it's 0 and -1. And if you didn't put the else there, we would always check all 3 conditions.
Okay, then we continue with implementing those functions, and we maybe start with the player input because this is the first thing that's an open to do. And now what should we do here? So it would be really nice to have some player input, and I will define it or initialize it with 0. Then I want to really read input from user. Yeah, so I really have to do this action. And I also want to check for valid input. Yeah, and if the input is not valid, then I just want to repeat this as long as there is a valid input from the user. And after I've done this, I eventually want to return the input when it becomes valid. Okay, and how to do this now? So I probably write something like this. So your choice, the player should input something, and now you would use scanf directly in the assignment, and to avoid this now, to not spoil everything, I will use this getInput function, yeah, which returns me the character, the input, which returns me the character the user entered. Yeah. So we have this read input from the user. So I will write this equivalent to scanf right now. But we have not checked for validity, which we need to add. And now probably would ask something like, if the player input is correct, then we would, if it's not correct, then we would want to have another input. But if it's not correct either, then we want to have another input and another input and another input. So it really looks like a loop. So we want to really implement this part where we get something from the user as a loop. And how long should this loop be repeated? Yeah, as long as the player input is not valid. So as long as the player input is not a big R and the player input is not rock, paper, and scissors. So as long as it's the player input is not any of those three characters, we want to repeat it here.
So what would be a difference to do while?
In the while loop, the condition is checked here at the beginning. So if the player input would be valid before the while loop, then we would not even enter the while loop. But as I assigned 0 here, this doesn't matter. So we really have one iteration of the while loop. In contrast, in the do while loop, the condition would be checked afterwards. So I can do this here as well. I write this here. So in this case, we would really go into the loop, read one input from the player, and then check the condition. And if it's not true, we would repeat it. So probably a do while loop is even better in this case.
Okay, just because I saw it in the chat, in the main function, that would also be an example where you could use a switch case. Yes, and so it's not okay if you only have the main function for A1, because one of the learning goals is learning how to use functions, and you will need functions in later assignments. So you also get point deductions if you're not using functions.
And as I also see in the chat, 80 lines for a function. Let's look on the function that we've created. This function has 10 lines. This function has, 55, 20 lines. Usually you don't need more than 30 lines. So if the function is longer than that, usually it does more than one thing. But here we really have the guarantee that everything does one thing. Yeah, we just have the inputs, compute the result, and then print something, and we really just read the input from the players. It's just really one thing.
So maybe try to think about what does my function do, and if it's more than just one thing, then maybe try to restructure. So like a function that reads the input shouldn't also maybe like check the input if it's correct or something. You can already separate it, as we did here, into two different functions.
You can also use here a while one, so an endless loop, and then if it's correct, then you exit the function, you return from the function. This is also an option here for the input. Yeah, okay. Then we continue with the next to-do. So we finished the first one, and we now continue with the second to-do, which is the computer input. And now the same base structure as for the player input is probably not completely wrong. So we have a computer input, which is, 0. And then we do something, and then we return again the computer input. And now, of course, the computer should have some random input, which is a bit hard for you at the moment. So we just use this function here to get the computer input. And this function, get random number, returns an integer from 0 to 2, so 0, 1, or 2. So based on the result, we want to say, for example, 0 is the rock, 1 is the paper, and 2 is the scissors. And now we can use some structure here again, some conditions here if the result is 0, 1, or 2, but now we use a switch case as it was already suggested in the chat. So we call the function get random number.
And just to answer a question in the chat, you can always call other functions within a function. So the main function is nothing special. We are already calling other functions in the main function, and we are already calling a function here within a function. So of course you can do that. You can call even the function you are currently in within that function, but maybe try thinking about it really hard if that really makes sense in your case, if you want to do that.
Okay, so I call now this getRandomNumber function. It gives me an integer between 0 and 2. So I have 3 cases here. So I created the switch case. And now I do what I said already before. If the case is 0, then I say the computer input is this paper. And if we have the case 1, then the computer input should be, no, it should be rock, right? Rock is the first. Rock, paper, and scissors. And it's quite important that you do not forget to write the break here, because otherwise you would enter, for example, in case 1, would execute this statement, so the computer input would be P, and if there was no break, then we would just continue in the switch case. So in this case, also the computer input would be S.
So we would never get a P.
Yeah. So we really need the break here.
Yeah. So that's just how C works within the switch case. It's a bit weird that this works differently than everywhere else, but that's just how it is.
Mm-hmm. Okay, and now we already created the computer input. And maybe, let's see what I can do this very quickly. We just want to check our program. So I will write here a printf, say player, %c, player input. And we do the same for the computer. And we want to try whether this already works. And for that reason, the compute result function, I would just implement it with a return 0, that it's implemented, but it doesn't do anything at this moment. So we compile. And if we run the program, then we enter, for example, the P. And I haven't done very beautiful prints. And I'll redo it. And this should be the computer, probably. Then we see, okay, we have a player output, we have a computer output, and of course draw, because I wrote 0 here.
Just to answer a question in the chat, because this might be useful. When you're writing in Visual Studio Code or in Codium, then tabs, you see, okay, there are 2 spaces, and you need to make sure to always have 2 spaces as indentation within your assignment. But if you are in a new line and just press tab, you also get 2 spaces. So you don't need to press space to get these spaces. You can also press tab a few times and you always get, as you can see, you get spaces. This works because you should have set down here the indentation to using spaces and then 2 spaces, because that's our style guide. If you're using the virtual machine, this should already be set up. But if you're working on your own machine, then please check that you're using spaces and not tabs.
Okay. Were those all the questions that you want to answer?
So, yeah.
Okay. Back to the program. I executed it now a few times, and you can already see, so I always enter this choice, and the player choice is P, computer choice is S. So this is what we had as an input, and the computer says now S. And in the next time it says P, and now it says P again. So this is really randomly happening. And my choice and the player choice always correspond, because this is what we want to print. So finally we have one function left, which is this compute result function. And now one case is very simple. Yeah. So if player, the player input, and the computer are the same. So both have rock, both have scissors, or both have paper, then we immediately have a draw. So in this case, we can really return 0 from the function. And now it remains what combination we have, whether the player or the computer wins. And as I do not have so much time left, I would just copy it right now, those conditions. So, and I unfortunately had some other names here. Okay, but let's see if the player has scissors and the computer has paper. The scissors cuts the paper, so the player wins. The player has paper and the computer rock, then the paper covers the rock, so the player wins. And if the player has rock and the computer has scissors, then the rock destroys the scissors. So in these cases, the player wins, and we said for the player win, we want to return 1. And in any other case, we do not have a draw, and we do not have that the player wins, so we return -1. And now we can really run the whole program. And if we have, for example, P and the computer has R, then the paper covers the rock, so the player won. And if we play another round, we have S, so both of them have S, so we have a draw. And now we have scissors and rock, and the rock destroys the scissors, so the computer won and we lost.
That worked out perfectly.
Yeah, very nice. Yeah, you can also find this code then in the on Notion. We will upload it along with the slides.
So I hope that helped you a bit structuring your program, how you can divide up tasks in functions, and so on.
And in particular, I want to mention again, this function has 10 lines, this function has 15 lines, this function has 15 lines, and this function has 20 lines. So we are really, really far away from 80 lines per function, and you should do this too. Yeah, you should also do not really come close to these 80 lines, because it's not necessary. Because really, if you split it up into logical functions that really do one thing, you need at most 30 lines, I think.
And if you do it from the beginning, like we did here, when we first thought about the program, okay, how can we split it up in subtasks, which we can write in functions? And we already from the beginning have this layout where we don't have much lines within a function. If you first write everything and then see, oh, there's way too much code in my function, then probably you will have more work copying code around, creating functions and stuff.
Okay, then we go back to the slides, to the summary. So what have we seen?
Okay, so we saw scope and lifetime and how they differ, how this looks on the stack, when you can access variables, when you can't, how functions work, how the stack with functions work, and also that values are copied to functions as parameters if you call them. And now with the last example, we also saw a bit how could you structure a more complex task.
Okay. Then there is one thing left. We have to see who won the Menti Quiz today.
So let's continue.
Okay. So Sakura won today. And it looks like with 4 correct questions. Yeah, very nice. And then we go to the questions.
Now let's continue with your questions.
So, and what we didn't mention at the beginning, the lecture starts today at 4:45. So we have now 10 to 15 minutes for your questions in between the 2 lectures.
Do you want to answer?
Ja, ich mache es vielleicht gleich auf Deutsch. Ja, du kannst dir, wenn du jetzt hier drinnen bist zum Beispiel, kannst du dir einfach mit Touch, was wir in der ersten Einheit gesehen haben, eine neue Datei aufmachen, zum Beispiel eigentlich test.c, und die hast du dann da drin und mit der kannst du dann auch arbeiten.
Und wie wir es heute schon gemacht haben, kannst du auch bei CLang, wenn du jetzt hier kompilierst, hier angeben, welchen Source-File du kompilieren willst. Dann kannst du entweder sagen, okay, ich will jetzt Test kompilieren, ich will Rock, Paper, Scissors kompilieren oder ich will Main kompilieren, und kannst dir auch andere Executables Namen hier aussuchen, und dann kannst du je nachdem immer das ausführen, was du gerade testen willst. Und das musst du auch nicht im Ordner vom Assignment machen. Du kannst hier zum Beispiel sagen Open Folder und dann einfach einen anderen Ordner aufmachen, wo du deine Tests drinnen machst. Okay, so we did that in the last stream at the very beginning.
Yeah. Or alternatively, there is also a guide on the Notion. Set up your device and then debugger in VS Code in VS Code.
Yes.
So here again is everything explained. Thanks to David, who created that page.
So yeah, or you watched the last stream. Exactly.
Where do we put the function header if we only declare the function in the beginning? It doesn't matter in this case. So the function, the header comment is meant in this case.
Yeah, I think if you declare a function and define it later where you put the header.
Yeah.
So we didn't define that, so I think it's up to you. I think it would be nice if you put it with the declaration.
Yeah.
Because then you have all the functions and what they do in one place, but it's up to you.
So you have like header comment, function declaration, header comment, function declaration, main function with a header comment, and then the implementation of the other two functions that you already described before. Yeah, okay.
But you don't have to do it this way.
Yeah, so it's not restricted in the style guide.
Yeah, so we just answered
This is the same question.
No, they are mostly going to be in person, but if there's if for some reason you can't come to university, you can also ask your tutor if you can do them online. Then you need a camera, so you can show your student ID.
Yeah, but this is only for really exceptional cases. We really want to have them offline at university.
No, you should use 2 spaces, or else you will get point deductions for the style guide.
How do I know what to use for a function? When do you use void function in parameters, for example? I mean, in this example that I coded right now, I always, when we created a function, I thought, what do I need for the function and what do I want to have from the function? So for example, if I want to have a user input, then I probably do not need parameters, but I want to obtain the result from the function. So I have really an integer or a double as a return value. If I want to do some computation, then usually I pass in some parameters that needs to be in this computation, and I obtain a result. For example, if I want to compute the game result, then I need as an input what the computer and the player have chosen, and I want to have the result as a return value. If I want to print something in a beautiful way, I usually only need to pass the parameters that need to be printed, but I will not get the result from this function, so then I use void.
Of course, there's also the alternative of just omitting it for now, writing your function and then figuring out what it returns and what needs while you write it. But I think it would generally be a better idea if you first have a clear idea of what your function should do and what its output is. Because then you also have a clearer idea of how you want to structure your program, and you probably save some time when you first think about it and then implement it instead of figuring everything out along the way.
Yeah, and it's also worth to mention we have one restriction, that is you just have 0 or 1 return values, but you cannot return 2 or 3 values, at least in assignment 1, because we haven't learned that yet.
Could we change the styling code for the next assignment so that opening brackets don't have to be in the online? This would make code more readable, or is this part of the official guideline? No, we won't change this. I think with these brackets in the online, it's more readable. And it's not just because I think we had the style guide for multiple years.
For really many years.
And it's also in C, you most often see code where these brackets are in the online.
Yeah.
So
particularly in C.
Yes, particularly in C, you see this very often.
There is a section on Discord where one can choose a tutor. Is this relevant? No, this is not relevant. You will be assigned to a tutor by us, probably next Thursday. And once you know who your tutor is, then you assign yourself to the correct channels on Discord.
Yeah, this is just so you are in the channel with your tutor.
Yes. But you do not choose your tutor there.
So, es ist nicht genau, es ist kein Parameter, nicht keine Return Value, aber ja, du kannst beide schreiben.
Ja. Wird beim Assignment jedes vergessene Leerzeichen sanktioniert oder wird auf Versehen? Ja, also wenn jetzt eine Kleinigkeit einmal falsch ist, dann ist halt eine Kleinigkeit falsch, das ist kein Problem. Aber wenn sich halt das ganze Assignment durchsetzt oder immer wieder irgendwelche Sachen passieren, dann gibt es natürlich Punkteabzüge.
Are you allowed to use commentators like this? No. You have to follow our style guide, but you can also set up in Codium or Visual Studio Code that it generates the documentation headers like this for you, because it already does this if you write them like this, but you can change that in the settings to use our style. Then it's,
So you don't have to write
these comments all the time.
Yeah. So
but please follow our style guide.
How can I see my completed test cases? My pipeline failed, but I don't get a precise error message.
On GitLab, there you see the pipeline running. If you click on it, on the right side, I think I posted a screenshot somewhere in the response to some question on a Discord. Maybe you can find that. There is a button where you can browse or download artifacts. And within those artifacts, there is the test report HTML, which is the same test report which you get when you run the test cases locally. There you can see the difference of the output.
So maybe I think it's also mentioned in the assignment 1 slides, if this works. Okay, this happens again here, doesn't matter. So basically you just go to the build jobs and then you see this, and when you click on passed or failed, you also on the right side, you also get the overview, what happened, and then you have this folder that you can download, what you mentioned. Yeah, and you only see this for public test cases. For the private test cases, you don't see what the difference is, but you only see that they are passed or not.
Of course.
Ja, globale Variablen sind Variablen, die in keiner Funktion stehen, also nicht in Main oder einer von mir kreierten Unterfunktion. Genauso ist es. Ja?
Also sobald die Variable in einer Funktion steht, ist sie nicht mehr global.
Ja, und globale Variablen sind eben nicht erlaubt. Yeah, are we allowed to use pointer structs enums? Yes, you can use them, but you probably will get asked in the assignment interview, and you should only use things that you really know. But if you know them, I mean, there's nothing that prevents you from using them.
Yes, global constants are allowed because constants are not variables, because variables can change and constant can't. Yeah.
And I think there is something on constants in today's.
Yeah, and just because you mentioned you can also use define. I think that was also part of the question. I'm sorry. You can use define. That's fine.
Okay, there are some questions left, but we need to stop now because the lecture will start in 30 minutes. We will go through the questions and maybe have a short Discord post and answer the relevant ones there. Thanks for your attention today, and it will be very interesting in the lecture. And yeah, probably good luck for the remaining part for assignment 1. And yeah, you will do this. And in the next stream, you already submitted assignment 1, so the first task is already done. Okay, then have a nice evening and watch the lecture, and we'll see us next week.
Bye.
Bye.